Okay, so last class we talked about resistors in series and we talked about resistors in parallel, and we had some definitions about what is a resistor in series and when do you consider two resistors in parallel or more than two. So let's just summarize the properties of circuits in series and circuits in parallel. All right. So a circuit in series, two resistors in series looks like this. One resistor, then the other one after that. All right, we have R1 and the other one's R2. So what do we know about the currents that are going through resistor 1 and resistor 2? Because they're in series, right, we said that all the current that flows through one resistor has to go through the other resistor, otherwise current or charge will not be conserved. So we do know that in a resistor, in a circuit in series, if two resistors are in series, the current that flows through one of them is the same as the current that flows through the other one, which is the same as the current, the net current flowing in the circuit, or the current that flows through the battery, right? So that is regarding the currents. What about the differences in potential in this circuit? When they're in series, we know that we can move around that loop, writing Kirchhoff's loop law, and we end up with, if we move from the negative side of the battery to the positive side of the battery, we go up in potential epsilon, the EMF of the battery. When we move through one of the resistors, say resistor 1, we drop in potential, right? Remember the battery is putting all this water up here, and then the water is going to flow downhill. The direction of the current is going to be from positive to negative. So when you go across resistor 1 following the current, you're dropping in potential, right? So that is, you write that with a minus sign because of that. And at this point, then you move through resistor number 2, and that's another drop in potential. You're still going with the flow of the current, so you're dropping, you're going towards lower ground. So that goes with a minus sign also. Minus IR2. And because now you're back to the original point, the point where you started your journey, then the sum of all of the potential changes should be equal to 0. Okay? So from this we conclude that the potential drops of the resistors in a circuit in series, they add up. You take one, you take the other one, you add them, and that should be equal to the voltage of the battery. Right? So that's for a series circuit. You add the differences in potential for the resistors that you have. You could have, 3 resistors instead of 2. You could have an additional third one at the bottom, and of course you would do the same thing. The currents are all the same, and you will do that. You would end up with the epsilon being equal to IR1 plus IR2 plus IR3. Right? So that wouldn't be different. So those are the properties of the major properties of a circuit in series. So the voltage drop, they add. And the current is the same. Now for two resistors connected in parallel. So you have your battery. This is the positive side. We know that these two guys are in parallel because one resistor is connected to the other resistor with a cable, with an ideal cable, an ideal conductor. Both sides of them. So there is a cable that starts. I can start walking from one resistor, follow a cable, and I can end up on the other resistor. And I haven't had to cross a battery or a resistor or anything like that, just moving continuously on a cable. And I can do the same thing on the other side. From here, I can walk all the way to the other resistor. So that makes those two resistors in parallel. Okay? So for resistors in parallel, we have that the currents are no longer going to be the same because now the appropriate Kirchhoff law that we need to use is the fact that because current is conserved, the current that goes into, say, this node here should be equal to the amount of current that goes out of that node. So I'm looking here, I'm standing here, measuring the current that is coming in, measuring the current that is coming out. So what comes in should be equal to what comes out. If I call the current going through resistor 1 I1, and I call this current I2, and the overall current I, we know that I should be equal to I1 plus I2. So instead of the currents being the same as in the series circuit, now the currents add up to the total current in the circuit. And now what's going to be the same is the difference in potential across the two resistors. Because notice that those resistors are connected between two points that have the same difference in potential. That is, resistor 1 is connected to this red line over here, which you can think of it as having the same potential. Everywhere I'm drawing red has the same electric potential, and everywhere you see blue, those points have the same potential. Not the same as before, but the same among them, between them. So all of those blue points are connected to the negative side of the terminal of the battery, so they have the potential of the negative side, and the red ones have the potential of the positive side of the battery. So both resistors are connected between those 2 points, between the red level, which is higher above the ground, the electrical ground, between the red level, which is high ground, and the blue level, which is ground level, right? So that means that their difference in potential is the same. So delta V1 is equal to delta V2. And if you were moving, following the direction of the current, as you move through those resistors, then the potential drop, which goes with the minus sign, will be equal to the potential gain as you go through the battery, just from conservation of energy. Okay, now let's look at some circuits and try to figure out whether the resistors that I'm going to show you are connected in series or in parallel. Okay, so the first one I want to show you looks like this. And clearly we are measuring the resistance between this point and that point, right? That's where you would connect the battery. Sometimes the battery is not shown, it's just a question about what's the resistance of the circuit. Knowing that if you wanted to use that circuit, you would connect a battery between the 2 points, the 2 end points of the circuit. Okay, so if this is what you have there, this is how they're connected. You can call this one R1 and R2. Are these resistors connected in series or parallel? Series or parallel? Right. So we know that because you can go from one resistor to the other moving along a cable, continuous cable. All right. Let's try another one. So parallel, right? That's the answer here. Another one. R1, R2, R3. And the question is R1 and R2 series or parallel? Okay, so if it was series, what is the property that tells us that R1 and R2 are in series? They must satisfy that if a current goes through 1, if I1 goes through resistor 1, R2 must have exactly the same current. The current that flows through 1 must flow also through 2. Is that satisfied here? Let's follow the current. The current is flowing here, goes through resistor 1, and what happens at this point? it has an option, right? It can either go to the right or it can go to the left. Some of it is going to go to the left because why not? And some of it is going to go straight, right? So that makes the current that flows through resistor number 2, which is I2, it's going to be different than the current that flows through resistor 1. And you can be sure that I2 is going to be less than I1. Okay, I2 is only part of I1. The other part is flowing through resistor 3. Okay, so R1 and R2 are neither in series nor in parallel. That's what you call a trick question, right? Okay, what about 2 and 3? Are they in series or in parallel? Or neither? That should be parallel. I think that you all see that. Because they're connected by a continuous cable on this side and on that side, right? Okay, next circuit. This one I'm showing you explicitly where I'm going to put the battery. Series or parallel? If you think it's series, raise your hand. If you think they're in parallel, raise your hand. Okay, so series. You don't look at the geometry of them. You look at how they're connected to decide series or parallel, right? Don't go with your instinct about, oh, they look in parallel, they must be in parallel. You have to slow down for a second. Okay.